All right, 8th graders, this is to help you with question 7 on CR 16. It says on the grid, draw a trapezoid, tops, which is congruent to trapezoid park. Okay, so we want to draw a trapezoid and we're going to call it tops. And we need it to be congruent to park. So T will correspond to P, O will correspond to A, P will correspond to R, S will correspond to K. All right, so if I want a trapezoid that's completely congruent to the given trapezoid, if PK is 1, 2, 3, 4, 5, 6, 7 units long, seven units between P and K, then between T and S, because T corresponds to P, S corresponds to K. So between T and S, I need to have 7 units. So I'm just going to start here. I'm going to call this S. I'll count back 7 units. 1, 2, 3, 4, 5, 6, 7. And I'll call that T. And so from T to S, that also must be 7 units long. All right, so if from K to R is 1, 2, 3 units, K to R is 3 units, then S to P must be 3 units. So I have to go up 1, 2, 3 units, and I'll call that P. Oops. Sorry about that, call that P. All right, because this is 3 units. From there to there. So over here, it must also be 1, 2, 3 units. From P to S. All right, R to A is 1, 2, 3, 4, 5 units. So if I need to create a congruent trapezoid, so R to A was 5 units, so P to O must be 5 units. 1, 2, 3, 4, 5 units. Call that one O. That will still be 5 units. Connect those back up. These trapezoids are completely congruent. Congruent. Exact same size, exact same shape. Oops, trying to spell the word size. Congruent would be the exact same size, exact same shape. Exact same area. Corresponding angles match. Etc., etc. It's that all of those properties, when we talked about rigid motions, translations, reflections, rotations, area remains the same. Corresponding angles remains the same. Distance remains the same. Perimeter remains the same. Area remains the same. So those are congruent figures. And I actually took this figure and all I did was translated 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right. I just translated it 10 units to the right, and therefore it will be congruent. If you can get there using translations, reflections, rotations, you'll be able to create a congruent figure. All right. It says, then draw a trapezoid fend, which is similar but not congruent to park. Okay, fend is similar but not congruent to park. Label the trapezoids, explain why they are congruent and similar. Okay, up here I explained why these are congruent. Down below I'll explain why they're similar. The ones I'm going to create now are similar. So they want me to take fend, and they want fend to be similar to park, but not congruent. All right, on another video, I talked all about corresponding parts and that with similar figures, the sides are in proportion. What I'm going to do is I'm going to take my original park and I'm going to dilate it by a scale factor of 2. So if I take park, I'm going to take each of my sides and make them twice as long to create Fend. You could make each of your sides half as long. You could triple each side. The sides are going to be in proportion. So I'm going to take park and I'm going to dilate it by a scale factor of 2. Then I'm just going to put it somewhere else on the grid. So we have P to K. P to K. P to K will end up being F to D, right? F corresponds to P, E corresponds to A, N corresponds to R, D corresponds to K. So PK will turn into FD, goes to FD. So if PK is 7 units long, I'm going to multiply that by 2, and I need to make FD 14 units long. So I'm going to just draw it down here at the bottom so I'm sure I have enough room. So FD I want 14 units long. So I make this right here. I can choose to put it anywhere on the grid I want. F, and I want it to be from F to D 14 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and there's D. Did I count 15? I want it 14 units long. So now I got to double count, make sure. Oh, this is going to be a long video. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, good. So this right here is now 14 units long. Because 7 times 2 gets me to 14. So then I'm going to look from K to R. We know KR was 3 units long. So now I'm going to take 3 times 2, come up with 6. So if I look here, KR is going to correspond to DN. KR will correspond to DN. So DN has to be 6 units. So from D, I have to go up 1, 2, 3, 4, 5, 6 units. I have to call that N. Let me just double check. 1, 2, 3, 4, 5, 6. Yes. And you might say to yourself, well, how did you know you had to go up straight up on that grid line? Well, the original angle K was 90. So my new angle D also had to be 90. So I knew to go straight up. All right, finally, R to A. R to A is 5 units. And what does RA correspond to? RA corresponds to NE. RA corresponds to NE. So if I take 5 times 2, because I've decided to double up all the sides, that will make it similar but not congruent. 5 times 2 is 10. So NE must be 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This must be E. And I've made each of my side lengths twice as long now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, beautiful. So now these are similar. They're the exact same shape, but the new figure, each side length is twice as long. So to be similar figures, the angles remain the same. In similar figures, the angles won't change. Like however many degrees is up here in angle A, there's the exact same number of degrees in angle E. You can tell those are both obtuse angles. Here, angle F and angle P, those angles will remain the same, but corresponding sides are in proportion. But the sides on F, E, and D are twice the length of P, A, R, K. Similar, they're going to still be the exact same shape. They're still going to have the exact same angles, but you're going to either blow up or shrink down your sides by a certain scale factor. I chose to go with the scale factor of 2, so each of my new sides are twice as long. I hope that helps.